Morning, students. How are you all doing? Ikenezi, how are you? Okay, we're going to look at a topic today in basic science, which is light energy. Light energy. And we have two objectives we are going to achieve at the end of this class. One of the objectives is to explain the meaning of light energy. At the end of this class, you should be able to know how to explain what light energy is. The second one is to identify the properties of light energy. That is reflection and the refraction. Okay? Get your writing materials. Let's go. What did you see in that picture? What did you see? Light. Right? Yes, it is light. And what is light energy? Light is a form of energy which produces electromagnetic radiation capable of causing visual sensation. In other words, light is that form of energy which produces radiation which you can use to see. Without light, you cannot see. Hope you know that. Without light, you cannot see anything. So light produces that radiation which will help you to see. Light is a kind of electromagnetic wave that can travel in vacuum. Light is a kind of electromagnetic wave that can travel in vacuum. What is vacuum? A space containing nothing. Okay, so light travels in vacuum. Are you with me? Alright. Note this. Look at all this that I've written. Make sure that you note them. Listen attentively. If you have questions, ask. But listen attentively. Light is the fastest substance known to man. Yes. Light is the fastest substance known to man. So if you're asked, what is the fastest substance known to man? The answer is what? Light. And the speed of light is what? 3 times 10 raised to the power 8 meters per second. Yes. Light travels at a speed of what? 3 times 10 raised to the power 8 meters per second. Light travels in a straight line. And we call it rectilinear propagation of light until it encounters an obstacle. What does that mean? Light will continue to travel in a straight line until it hits an obstacle, say a wall. Are you there? So light travels in what? A straight line until it hits an obstacle. When light cannot pass through that obstacle, shadow is formed. Yeah. Light travels in a straight line until it encounters or hits an obstacle. And if light cannot penetrate into that obstacle, a shadow is formed. Are you listening? I believe you're listening. An object that does not allow light to pass through it is an opaque object. Why those ones that allow the passage of light are called transparent objects. Hope you do that. I'm sure you do. I'm sure you've heard this before, either in your grade 7 or 8. Yes. Any object that does not allow the passage of light, that object is called opaque object. While those ones that allow the passage of light are called transparent objects. So you can be able to know the ones that are opaque, the ones that are transparent. Can you list at least 2 of each of them? Opaque object and transparent objects. I'm going to ask you when next we meet. Those objects that allow the passage of light and those ones that do not. Write 2 of each. Okay, let's proceed. An object that can produce light on its own is called luminous object. Yes, that's true. That object that can produce light on its own is known as what? Luminous object. Example is sun, light bulb, and fire. For those ones that cannot produce light on their own but can reflect the light are called non-luminous objects. Examples are moon, mirror, some glass, not all glass, but some glass, etc. Are you following? If you are not, ask question. I will reply. I started by telling you the meaning of light energy. And light is the fastest substance known to man. The speed of light 3 times 10 raised to the power 8 meters per second. Light travels in a straight line until it hits an obstacle. And if light cannot penetrate into that obstacle, a shadow will be formed. Now, any object that allows the passage of light is called transparent object, but those ones that do not are called opaque. And the objects that can produce their light are called luminous objects. Why those ones that cannot? Non-luminous. Are you with me? Okay. We have properties of light, and there are 4. We are going to discuss 2. The remaining 2, you will discuss them or study them in your senior secondary school. So, we are going to discuss the 2 first properties of light, which are reflection and refraction. But we have 4 properties of light. 1 is reflection, 2 is refraction, 3 diffraction, and 4 interference. These are the 4 properties of light. We're going to start with the first one, which is reflection of light. Reflection of light is the change in the direction of light after dashing against a soft ray. Make sure you're writing. Make sure you're writing. Reflection of light is the change in the direction of light after dashing against a soft ray. Now, if a light should travel and hits an obstacle, and that object it hits is an opaque object, which is those ones that do not allow the passage of light, that light will reflect to move to another way, to just go. So, if you look at the diagram there, we have angle of incidence and angle of reflection. Light, angle of incidence is that ray where the light hits the obstacle. Then angle of reflection is that ray where the light leaves the obstacle. It is reflecting. So, reflection is the change in the direction of light after dashing against a soft ray. Reflection involves two rays of light, an incoming incident ray and an outgoing reflected ray. Draw the diagram showing the angle of incidence, which is the ray where the light hits the obstacle. Then angle of reflection where the light is leaving the plane. Okay? Are you with me? Alright. We have laws of reflection. There are two laws of reflection. One, the angle of incident ray, the normal, and the reflected ray at the point of incidence all lie on the same plane. If you look at that picture again, the angle of incidence and the angle of reflection and the incidence ray, the normal, lie in the same plane. That is the first law. At the angle of incident ray, the normal and the angle of reflected ray lie in the same plane. That's the first law. And the second one is the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to what? The angle of reflection. Yes. The angle of incidence, whatever you have gotten there, will be the same thing as the angle of reflection. These are the two laws of reflection. Now let's move into the second one, refraction, which is the bending or change in the direction of wave when it moves from one medium to another, where its speed is different. Yes. The bending or change in the direction of wave when it moves from one medium to another, where its speed is different. Now listen. Have you ever witnessed being sitting in a pool and placing your two legs inside the pool, sitting on that pavement, then dipping your two legs inside the pool? If you view your legs that is inside the pool, it will look as if your legs are bent. Have you ever witnessed that? If you have, that is what we call refraction. Something appearing like it is bent if you are viewing it, either inside water or light or anything. That is what we call refraction. Something appearing to be what? Bent. Now, refraction is responsible for image formation by lens and the eye. Note this. Refraction is responsible for what? Image formation by the lens and the eye. Look at the diagram. Look at the diagram. Are you seeing it? See the incident ray coming, while the refracted ray seems to be bending. Are you seeing it? And both of them are in opposite direction. That is what refraction means, a bending or change in the direction of wave when it moves from one medium to another, where its speed is different. Are you following? Okay, laws of refraction. You have two, just like a reflection. First one says the first law of refraction states that the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane, just like the first one. Then the second one says this law states that the angle of incidence to the angle of refraction, the sine of the angle of incidence to the sine of the angle of refraction is a constant in a given pair of median. This is what we call Snell's law in physics. The sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of median. These are the two laws of refraction. Note them and ask your questions. When you treat this, you're going to study this again in your physics, and we are going to discuss more on this Snell's law of refraction rather. Okay, these are the two things you're going to do. What is light energy? I want the answer immediately. Give me the meaning of light energy. Then write down the 4 properties of light energy and explain the 2 you have studied with suitable diagrams. I'm expecting the answers here. Okay? You have a good day.